If you've ever seen huge flocks of birds or a shoal of fish, you might have wondered how so many creatures are able to move together without colliding. Now, scientists at the University of Bristol believe that they have been able to explain how flocks of bats are able to avoid collisions by using just a few simple traffic rules. I spoke to Dr. Mark Holderried from the University of Bristol's School of Biological Sciences to find out why bats were such an interesting animal to study and how he hoped his research could help us design better robots.
The starting point for our research was when we saw these massive swarms of bats emerging from caves, and we were puzzled by how the hell they coordinate their movement. Hundreds, thousands of them densely packed, and they still move without colliding. That whole coordination problem is something that engineers in robotics have been struggling to replicate, and it's a bit like the holy grail to try and get close to what animals like the bats can do.
What is it about the way they communicate that is significant here?
Bats are special because they don't use vision to do whatever they do. They use biosonar. That means they orient by the echoes that bounce back from whatever is in their environment. Now that offers an opportunity for us to research that, because we can put microphones out there and record what they're saying, and then we can reconstruct what they're hearing. That allows us to understand the rules that they use to achieve this coordination.
How can you go from these complicated flocks of bats to something that you can actually describe? There seems to be a lot of information that you have to deal with there.
As a researcher looking at these flocks of thousands of bats, it's interesting, but it's also very, very challenging. Somewhere in there is the truth, but in order to reveal the truth, we have to move to a simpler problem. The steps that we took, first of all, we went from thousands to a pair. We looked at the interactions of two bats, and the other tricky bit is, as flying creatures, they can move up and down as well as left and right. We have chosen a species which flies in just 2 dimensions. It forages over water surfaces.
What simple rules have you found that govern the flight of bats?
When we studied this, we found really rich behaviors. So we saw that they sometimes chase each other, they fly in tandem flights, they do little formation dances. It gives us a lot to play with. When we put that into a model to try and understand how they do it, we were pleasantly surprised to find a very, very simple rule behind all that rich and complex behavior.
If I were a bat, what rules would I need to know to be able to stay alive and also get access to the best food?
Well, first of all, you want to listen to what your neighbor's doing. If he has seen a prey item, he will change its echolocation behavior, going into a so-called feeding buzz.
Those chirps you heard are the sound of a bat detecting and homing in on some prey. But if I were another bat and I heard that noise, what should I do?
You know that he has found prey. It would be a good idea to go there and check that site out. So that's a good idea to improve your foraging success by eavesdropping. But when you are close, you don't really know what the other guy is going to do, but it's a very safe and smart strategy to align with him and follow whatever he's doing. You can follow in a tandem flight or formation flight with a certain delay, between 1/10 of a second and 1/2 of a second. That's all you need to do.
You've effectively discovered the highway code for bats.
One analogy that I really like is a roundabout. So think about you driving up to a roundabout and a couple of other cars do the same from other directions. Now you arrive at the same time. What's most likely to happen is that all of you will stop, and then you have this awkward moment and one of you has just to go and resolve that. Bats face very similar situations all the time. What they can't do is to stop. If it stops, it falls in the water and drowns or has to swim away, risks being eaten by fish. The simple rule that we've discovered allows them to do exactly that.